Hi Chem students, and welcome to the third lesson of the bonding unit. We are starting today at the top of page 4, and we're going to be learning about creating Lewis structures. This is actually one of my favorite lessons probably of the year, because we finally get to see what all of these compounds that we're talking about look like. So me being a visual person, I like to see what they look like, and we'll get to build them in class and use little model kits, and it's fun. So I hope that you enjoy it also. So today we're learning how to create Lewis structures. Page 4, here we go. Okay, so in creating Lewis structures, follow this procedure to make Lewis structures for molecular compounds. So our first example is going to be the water molecule. The first thing you need to do is to draw the skeleton of the molecule. It says it generally works to place the different atom in the center. So in the water molecule, we've got 2 hydrogens and 1 oxygen. So oxygen is the different atom. So we're going to stick it in the center, and around it, we're going to put each hydrogen. So HOH is what I'm drawing for my skeleton. Okay, so number 2, find the needed electrons for each atom and add them up. N will be 8 for most elements except these exceptions. Hydrogen needs 2, beryllium needs 4, and boron needs 6. Yes, those do have to be memorized. So I've got hydrogen and I have oxygen in a water molecule. To figure out the needed, I'm going to say how many atoms I have. So I've got 2 hydrogen atoms, and each one needs 2 electrons. So 2 times 2 gives me a total of 4 for hydrogen. I've got 1 oxygen atom that needs 8 because it's not an exception. So that gives me 8 total. I'm going to add them up, and I get 12 for my needed number of electrons in a water molecule. Step 3, find the available or valence electrons for each atom and then add them up. Okay, so again, I've got hydrogen and oxygen. There are 2 hydrogen atoms that each have 1 valence electron. We've got 1 oxygen atom that has 6 valence electrons. So 2 and 6, adding them up, I have 8 available or valence electrons total. Okay, step 4. You're going to find the shared electrons for the entire molecule by subtracting N minus A. So N was 12 and A was 8 for the water molecule. So our shared electrons are 4. The shared electrons are your bonding electrons. Place all of the shared electrons between the atoms. So it's really important that these shared electrons go between the atoms because they're your bonding electrons. So it takes 2 electrons to equal 1 bond. Super, super important. So I'm putting 2 here between hydrogen and oxygen to bond those together, and 2 here to bond them together. So I'm making 2 single bonds. Step 6. You must place all of the available electrons in the picture. The shared electrons are part of the available. See how many of the available electrons still need to be placed and put them in the picture as lone pairs or unshared pairs so that every atom gets an octet. I tend to focus on that more than making sure I used all of the available. I just make sure that all of my atoms are happy. And so remember that hydrogen just needs 2. So these hydrogens are perfectly happy. If you look at them by themselves, so just here, the hydrogen's happy. It's got 2 electrons. So is this hydrogen. Super happy. It's got 2 electrons. But if we look at oxygen, oxygen needs 8, and it currently only has 4, 2 on its left and 2 on its right. So it actually needs 4 more. So that's where I'm adding those lone pairs to make sure that the octet rule is fulfilled. So now we have the completed picture or Lewis structure of our water molecule. Okay, more practice with Lewis structures. I'm going to do a couple more and then I'm going to have you pause it and try these on your own. The first thing we want to do is calculate our NAS. Some teachers call this NOS, I just call it NAS. So our needed, our available, and our shared electrons. Okay, so first we're going to deal with needed. This fulfills our octet rule. So carbon needs 8 electrons to be stable and happy. And hydrogen, there are 4 of them that each need 2 in order to be stable. Remember that hydrogen is an exception. So 8 plus 8 gives me 16 needed electrons. Then available. When you think of available, think of valence. So carbon has 4 valence, plus our 4 hydrogens have 1 valence each. This is 8 total available electrons. And then shared, where you can think of it as subtract, is 8. So to get your shared, you just do N minus A. So if you write it this way, NAS, it makes it really easy just to subtract and see that you have 8 shared electrons. Okay, so next I'm going to draw my skeleton. Carbon is going to go in the center. I'm going to put my hydrogens around it. I'm going to use those shared electrons to bond these together. 2, 4, 6, 8. Remember, you have to use electron pairs to make a bond. So 2 dots have to be present to bond these together. So I've used my 8 shared, and I'm going to look at my picture and see if they're happy. If I look at carbon in the center, it has 2, 4, 6, 8 electrons touching it, so it is happy. And each hydrogen just needs 2, so it is also happy. This is my completed Lewis structure for methane, CH4. Okay, so let's do another one, HCN, which is hydrogen cyanide. So I'm going to do my NAS for this. I have 3 different atoms here, so I'm not going to be multiplying, I'm just going to be adding together. Okay, so first, hydrogen just needs 2, plus carbon, which needs 8, and nitrogen, which also needs 8. This gives me a total of 18 needed electrons. A is valence. Hydrogen, if we look on our periodic table, it has 1 valence, carbon has 4, and nitrogen has 5. This gives me a total of 10 available or valence electrons. For shared, I subtract, and I get 8 shared. So now that there's not one atom that's different, I'm just going to write these in a row. So hydrogen, carbon, nitrogen. And I have to use these 8 shared electrons. Well, only 2 electrons can go on hydrogen. That is the max. It can't hold any more. So I'm bonding hydrogen and carbon together singly. You can only have single bonds on hydrogen. That's a really good little point to make. But then I've got 6 extra electrons I have to put somewhere. They're going to go between carbon and nitrogen to make me a triple bond. I've got 6 electrons being shared here and 8 here. Next, I need to check and see if my atoms are happy. So if I look at hydrogen, it's happy because it just wants 2. If I look at carbon, it's got all of these electrons on it. So 2, 4, 6, 8. Carbon's happy. Nitrogen just has these 6 touching it, so it's not happy. I actually have to add 2 more electrons as lone pairs to make nitrogen stable. Now I have my completed Lewis structure. Okay, let's try drawing the Lewis structure of a polyatomic ion. So ions are a little bit special because they're charged. Let me show you how we do the NAS a little bit different. Okay, so nitrogen, it needs 8 electrons, and my 4 hydrogen atoms each need 2. So 8 plus 8 gives me 16 needed. A is available. So nitrogen has 5 valence electrons. My 4 hydrogens each have 1 valence electron. So I think that I have 9 valence or available electrons, but that's not true. This is an ion. So that positive 1 means something. The positive 1 means that it has lost an electron. So there actually aren't 9 available. There are 8 available because it has lost an electron. So you do the opposite of the charge to A. I'll say that again. You do the opposite charge of your ion to your available or your A value. So if it's positive 1, you're going to subtract 1. If it was positive 2, we would subtract 2. If it was negative 1, we would add 1. So I have 8 available electrons. Shared, or S, is 16 minus 8, which gives me 8 shared electrons. Now I'm going to draw my Lewis structure. So remember, the odd atom goes in the center. So nitrogen is going to go in the middle with 4 hydrogens around it. Now remember, hydrogens can just singly bond. So first I need to use these 8 shared electrons. You always start by looking at your shared and using those first. So I'm going to singly bond each hydrogen to the nitrogen in the center. And by doing that, I'm using 2, 4, 6, 8 electrons, which is the total shared. Now I'm going to assess my Lewis structure to make sure that all of my atoms are happy. Each hydrogen has 2 electrons around it, so they are happy. And my nitrogen has these 8, 2, 4, 6, 8, so nitrogen is happy as well. Now, when you're drawing the Lewis structure of an ion, you need to finalize it by putting it in brackets and putting the charge outside of it. Okay, there are 3 remaining Lewis structures that need to be drawn at the bottom of page 4. So I want to give you the chance to try it on your own. So pause the video and try these 3 on your own and come back to see if you did them correctly. Okay, welcome back. Let's see how you did. For the nitrate ion, it should look like this. Oxygen should look like this. And sulfur dioxide should look like this. If you have any questions or you did this incorrectly, please raise your hand and ask your teacher at this time. Otherwise, I'm going to continue the last little piece of this video on the next page, the top of page 5. We are about to tackle resonance forms. Sometimes more than one correct Lewis structure can be drawn for a compound by changing the location of a double bond, for example. These are called resonance forms. Consider the possibilities for nitrate. Okay, so in this nitrate that's shown, you see that there are 3 places where the double bond could be located. We just chose the top position for the first location of the double bond. But someone else could have chosen to draw that bond here. And then lastly, the bond could have gone here. So we've got the top, the bottom left, and the bottom right positions that are all possible. It says at the bottom, in reality, the extra pair or pairs of electrons are free to move in different bonding positions. The true picture of the molecule is one that is a blend or a hybrid of all resonance forms you can draw. So this is what we mean by resonance forms, when you have the choice where to put the double bond in your Lewis structure. Okay, that concludes my video for today. I hope you were able to understand and that you got some help with drawing Lewis structures today. If you have any questions, raise your hand and ask your teacher. Also, you can start working on your practice packet. Have a great day.